Okay, in this video I'll do some example problems where what we're doing is looking at the relationship between subset and set membership. So the subset symbol looks like this, the set membership symbol looks like this, and is read is an element of. And the basic idea here is that we want to take into account the fact that sets can be members of others, can be elements of other sets, and make sure that we understand the relationships properly here. And in each case here it says, is it true that this statement is true? And we're going to answer those. So for part A, it says, is it true that the set containing the numbers 0 and 1 is a subset of the set containing the numbers 0, 1, and 2? And the answer is yes, because on the it's a subset question, and on the left we have a set that contains two elements, and on the right we have a set, and each of those two elements is in fact contained within the set on the right, so we say yes. Okay? Part B. Is it true that the set containing numbers 0, 1 is a subset of the set containing a set and the number 2? And so the only number that's in the set on the right is the number 2. The other thing in the set on the right is another set that contains the numbers 0, 1. Okay? And what we're looking for is the actual numbers 0 and 1 being in the set on the right. And they are not. The number 2 is, and there's another set that contains the numbers 0 and 1, but they're not the numbers 0 and 1. So this is a no. Part C says, is the set containing the numbers 0, 1 an element of the set on the right? And this is that same set we just had. And so this is true because this entire set is an element of the set on the right. And so the answer is yes, it is an element, and that's and the reason is that the set on the right has another set in it, which is the set containing the numbers 0 and 1, and that's exactly what we have on the left. For part D, we have, is 0 an element of this set on the right? Well, the set on the right doesn't have any numbers in it, so the answer's got to be no. Now, it has 3 sets in it, and one of them contains the number 0, but the number 0 itself is not in the set on the right, which is the set that uses these two brackets. So this is a no. Part D, is the set on the left a subset of the set on the right? And the set on the right contains 3 elements. Each one is a set. And the set on the left contains 1 element, one of which is a set, and which is one of the sets in the set on the right. So this is a yes. Okay? And now we want to know is, for part F, it says, is the set containing the number 0 a subset of the set on the right? And if a set is going to be a subset, its elements have to be in the set on the right. The element, there's only one element in the set on the left, and that's the number 0. And the set on the right doesn't have any numbers in it. It has sets in it. And those sets contain numbers, but the numbers aren't directly in the set on the right. So this is a no. Next, part G. Is the set on the left a subset of the set on the right? So what we're going to do is we're going to go through one element at a time and see if it's in the set on the right. And the set on the right contains all the elements within the circle I just drew here. And the 0 is there as a number. The set containing a 1 is there as a set containing a 1. So this is a yes. Everything on the left is in the set on the right. Finally, is the empty set an element of the set on the right? I don't see the empty set within the brackets, and so I'll say no. This one may be a little bit tricky because the empty set is a subset of every set. So if we asked if the empty set is a subset of this thing, then the answer would be yes. Okay, so hopefully these help fix in your mind the relationship between subset and elementhood. Hope this helps.